Hello dear students, in this session we will solve problems based on properties of inverse trigonometric functions. Before we start solving the problems, let us recapitulate what we learnt in our previous classes. The first main thing what you have to know is the domain and range of inverse trigonometric functions. So if you see in this table, first one, sine inverse of x. Its domain is closed interval minus 1 comma 1 and its range is closed interval minus pi by 2 to pi by 2. Second one, cos inverse of x. Its domain is closed interval minus 1 comma 1 and its range is closed interval 0 to pi. Third one, cosecant inverse of x. Its domain is r minus open interval minus 1 comma 1 and its range is closed interval minus pi by 2 to pi by 2 minus the set containing 0. Fourth one, secant inverse of x. Its domain is r minus open interval minus 1 comma 1 and its range is closed interval 0 to pi minus the set containing pi by 2. Next one, tan inverse of x. Its domain is the set of real numbers and its range is open interval minus pi by 2 to pi by 2. Next one, cot inverse of x. Again here, domain of cot inverse of x is the set of real numbers and its range is open interval 0 to pi. Students, if you observe this table carefully, what you can see, the domain of sine inverse and cos inverse same. And the domain of cosecant inverse and secant inverse, that is also same. It is r minus open interval minus 1 comma 1 and the domain of tan inverse and cot inverse same. So you can remember in this way. Two inverse trigonometric functions have the same domain. Well, coming to range, you can observe here students, range of sine inverse you have closed interval minus pi by 2 to pi by 2 and cosecant inverse range is closed interval minus pi by 2 to pi by 2 minus the set containing 0. So here also see, the range is same, minus the closed interval minus pi by 2 to pi by 2, but we remove 0 from that interval. Then it will become range of cosecant inverse, whereas for tan inverse it is open interval minus pi by 2 to pi by 2. So you can consider these three as a group. You can group them. Which and all? Sine inverse, cosecant inverse and tan inverse. Same way you have other three trigonometric functions, and if you see their range, here you can see in range of cos inverse of x is closed interval 0 to pi, whereas range of secant inverse is again closed interval 0 to pi minus set containing pi by 2, means you are removing pi by 2 from the closed interval 0 to pi. And the last one, that is cot inverse of x, its range is open interval 0 to pi. So you can remember these three, okay, you can group them and you have seen they will satisfy the same property also that you have learnt in your last class. Next, let us see the properties of inverse trigonometric functions. That first one, you have sine of sine inverse of x is equal to x provided x belongs to closed interval minus 1 to 1. So this will satisfy only when x will be between this closed interval minus 1 to 1, that you have to remember. Whenever you are having sine inverse of x, this x will take real values. Coming to second one, you have here sine inverse of sine x. This will be equal to x provided this x belongs to closed interval minus pi by 2 to pi by 2. Whenever we are writing sine of x, means this x will become an angle. So that angle should be between minus pi by 2 to pi by 2, between that range. Then you can write sine inverse of sine x as x. Then let us see the next property, that is sine inverse of 1 by x is equal to cosecant inverse of x provided x greater than or equal to 1 or x less than or equal to minus 1. Next one is cos inverse of 1 by x, that is equal to secant inverse of x, where x is greater than or equal to 1 or x is less than or equal to minus 1. Third one is tan inverse of 1 by x is equal to cot inverse of x, where x is strictly greater than 0. Next property, you have sin inverse of minus x is minus sin inverse of x, where x belongs to closed interval minus 1 comma 1. And tan inverse of minus x is equal to minus tan inverse of x, where x belongs to the set of real numbers. Then cosecant inverse of minus x is equal to minus cosecant inverse of x, where mod x is greater than or equal to 1. In the beginning, I told you can group here also see the same set of inverse trigonometric functions which will satisfy this property here. Sin inverse, tan inverse and cosecant inverse. Next, if you see the other inverse trigonometric functions, it will satisfy another property. It will be like this. Cos inverse of minus x will be pi minus cos inverse of x, where x belongs to closed interval minus 1 comma 1. Secant inverse of minus x is equal to pi minus secant inverse of x, where mod x is greater than or equal to 1. And cot inverse of minus x is equal to pi minus cot inverse of x, where x belongs to R. Next property is sum of two inverse trigonometric functions. Here you are taking the inverse trigonometric function with the inverse of its co-function, and that sum is always pi by 2. You can see here sin inverse of x plus cos inverse of x is equal to pi by 2, where x belongs to closed interval minus 1 comma 1. And tan inverse of x plus cot inverse of x is equal to again pi by 2, where x belongs to the set of real numbers. Third one, cosecant inverse of x plus secant inverse of x is equal to pi by 2, where mod x is greater than or equal to 1. Next property is the sum of two inverse trigonometric functions, sum of two inverse tan functions. So here you can see tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy, where xy is less than 1. Second one, the difference of those inverse trigonometric functions, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy, where xy is strictly greater than minus 1, whereas tan inverse of x plus tan inverse of y will become equal to pi plus tan inverse of x plus y divided by 1 minus xy if xy is greater than 1 and both x and y are greater than 0. Up to here, you learned these properties in detail in your previous class. In this class, we will prove another property of inverse trigonometric functions, then we will solve problems. So, the last property of your inverse trigonometric function is this one. In that first result, you have 2 tan inverse of x is equal to sin inverse of 2x divided by 1 plus x square, where this mod x is less than or equal to 1. Second one, 2 tan inverse of x is equal to cos inverse of 1 minus x square divided by 1 plus x square, where x is greater than or equal to 0. Third one, 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square, provided minus 1 less than x less than 1. If you see these three results, what you can observe, the left hand sides of all the three results is same. It is 2 tan inverse of x. In the first result, we wrote this 2 tan inverse of x in terms of sin inverse. In the second one, we wrote this same 2 tan inverse of x in terms of cos inverse. And in the third result, we wrote that same 2 tan inverse of x in terms of tan inverse. Let us prove these three results one by one. In the proof of these three results, we will take tan inverse of x as y. So in proof, first we need to consider, students, tan inverse of x is equal to y. Then x will become tan y. Next, you are taking the right hand side of result 1. Let us prove the result 1. So let us take right hand side of result 1, that is sine inverse of 2x divided by 1 plus x square, that is equal to sine inverse of, now you replace x by tan y. So it will become what? 2 tan y divided by 1 plus tan square y. Now this is the formula of sine 2y which you already learnt in your first PU. So remember students, here whatever formulae you learnt in first PU, its application will be there in second PU. So you have to be thorough with all the formulae of your trigonometry. Okay, so what is this? 2 tan y divided by 1 plus tan square y. This is the formula of sine 2y. So we can replace this as sine 2y. This one you write as it is. So it is sine inverse of sine 2y, and this will become is equal to 2y, provided this 2y should be between minus pi by 2 and pi by 2, that you have seen as the first property. Sine inverse of sine x will become x when x belongs to closed interval minus pi by 2 to pi by 2. Now keep that in your mind. We will continue here. So we got here 2y, and this 2y can be written as 2, and our y is what? Y is tan inverse of x. So we got here 2 tan inverse of x. So what we proved here, 2 tan inverse of x is equal to sine inverse of 2x divided by 1 plus x square. Here I told this 2y should belongs to closed interval minus pi by 2 to pi by 2. If 2y belongs to that closed interval minus pi by 2 to pi by 2, then y belongs to, divide by 2 now, it will belongs to minus pi by 4 to pi by 4. So y belongs to minus pi by 4 to pi by 4 means what is our y? Y is tan inverse of x. So tan inverse of x belongs to closed interval minus pi by 4 to pi by 4. That implies x belongs to closed interval minus 1 to plus 1. That is nothing but mod x less than or equal to 1. Okay. So this 2 tan inverse of x you can write as sine inverse of 2x divided by 1 plus x square, provided mod x is less than or equal to 1. Let us go to the second result. Second result also you will take tan inverse of x as y only. If you take tan inverse of x as y, then x will become tan y. So let us take the right hand side of our second result, that is cos inverse of 1 minus x square divided by 1 plus x square, that is equal to cos inverse of 1 minus, now replace x by tan y. So this x square will become tan square y divided by 1 plus tan square y. Now students, this is the formula of what? This is the formula of cos 2y. So we will get cos inverse of cos 2y. Next, cos inverse of cos 2y will become what? 2y, and that is equal to 2 times what is our y? Y is tan inverse of x. So we proved here 2 tan inverse of x is equal to cos inverse of 1 minus x square divided by 1 plus x square. So how did we start our proof? By taking tan inverse of x as y. Then x will become tan y. Then we will take the right hand side of our result. Then we will replace x by tan y. When we replace x by tan y, then we will get a standard formula here. This is the formula of cos 2y. Then we will be having cos inverse of cos 2y. Cos inverse and cos you can cancel. This will give us 2y, that is equal to 2 tan inverse of x. Here you can write cos inverse of cos 2y as 2y, provided this 2y should be in the range. What is that range? 2y should belongs to closed interval 0 to pi. So if 2y belongs to closed interval 0 to pi, then y belongs to closed interval 0 to pi by 2. What is our y? Y is tan inverse of x. So tan inverse of x belongs to closed interval 0 to pi by 2 means x belongs to 0 to infinity. If you see the graph of tan inverse, it is from 0 to infinity, means all positive values. So the condition for the second result is, you can write 2 tan inverse of x as cos inverse of 1 minus x square divided by 1 plus x square, provided x is greater than or equal to 0. X is positive real number. Next, let us see our third result, that is tan inverse of 2x divided by 1 minus x square is equal to tan inverse of, you know how we will write this x as tan y. Why? Because we have taken in the beginning tan inverse of x as y. So x will become tan y. So replace x by tan y in the given expression. So it will become tan inverse of 2 tan y divided by 1 minus tan square y. That is equal to tan inverse of, now this is the formula of tan 2y. So you have with us now tan inverse of tan 2y, that can be written as a 2y, and that is equal to 2 times y is nothing but tan inverse of x. So we showed 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square. And when you can write like this, tan inverse of tan 2y as 2y, provided this 2y belongs to the open interval minus pi by 2 to pi by 2, because the range is from minus open interval minus pi by 2 to pi by 2. Okay, so 2y belongs to open interval minus pi by 2 to pi by 2 means y belongs to open interval minus pi by 4 to pi by 4. Means what? Tan inverse of x belongs to minus pi by 2 to pi by 2 means x belongs to minus open interval minus 1 to plus 1. So you can see here that condition, x should be strictly greater than minus 1 and it should be strictly less than 1. So you can write 2 tan inverse of x as tan inverse of 2x divided by 1 minus x square, provided that x lies between minus 1 and plus 1. You can see it is strictly greater than minus 1 and it is strictly less than plus 1, because our range is open interval minus pi by 2 to pi by 2 for tan inverse. So we proved the seventh result, and to prove this result we have considered what? Tan inverse of x as y, then x will become tan y, and we took the right hand side and we replaced x by tan y. When we replaced x by tan y, we got our standard trigonometric formulae. Then we simplified and we got that finally as 2 tan inverse of x in all the 3 cases. So proof of this result is very important. Next students, let us solve problems using these properties. So the first problem is, you need to show tan inverse of 1 by 2 plus tan inverse of 2 by 11 is equal to tan inverse of 3 by 4. If you see the left hand side of this equation, what you can see? You are having tan inverse of 1 by 2 plus tan inverse of 2 by 11. So which property you can use here, students? You can use the property tan inverse of x plus tan inverse of y, which is given by tan inverse of x plus y divided by 1 minus xy. So let us use that property. Again I repeat, the property is tan inverse of x plus tan inverse of y, which is equal to tan inverse of, if you see the numerator, you are adding these two real values, tan inverse of x plus y, numerator add the values, divided by 1 minus xy, product of those two real values. Okay, so let us use this in this problem. So first let us consider the left hand side of this equation, that is tan inverse of 1 by 2 plus tan inverse of 2 by 11. Now apply the property. So when you apply the property here, it will become what? Tan inverse of, add the values in the numerator. So it is half plus 2 by 11, entire thing divided by 1 minus product of these two values, 1 by 2 into 2 by 11. Next, we need to simplify this. So this will become equal to tan inverse of, how to simplify? Here you have in the denominator 2 and here you have 11. So you need to take the LCM. Let us here cross multiply. So 11 into 1, 11 plus 2 into 2, 4 divided by, when you multiply these two, you are going to get 22. That is about the numerator. Now coming to the denominator. So write then entire thing divided by, here 2 into 11, 22, and here you have 1. So you need to multiply this 1 by 22. So you are going to get 22 minus 1 into 2, that is 2, divided by 22. Now you can cancel these 22. Then you are left with tan inverse of 11 plus 4, that is 15, and 22 minus 2 is 20. Here we have cancelled these. Next, you can simplify this one. So it is tan inverse of 5 3s are 15 and 5 4s are 20. So it will become tan inverse of 3 by 4, which is our right hand side. So we have proved this expression. Okay. So how did we prove? We started by this property. You need to apply here. When you see this left hand side only, you should be able to make out we are going to use this property to solve this problem. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Next, let us see the second problem. That is, again you need to show tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. So which property we can use here, students? Again you need to use the same property, that is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus x into y. So let us take the left hand side. So left hand side you copy as it is, then you use that property. So if you use this property here, it will become tan inverse of, I told you in the numerator you need to add those two real values. So it will become 2 by 11 plus 7 by 24, entire thing divided by 1 minus x into y. So you need to multiply them, 2 by 11 into 7 by 24. Next you need to simplify. So that is equal to tan inverse of, again you need to take here LCM. So let us cross multiply here, 2 into 24, 48 plus 11 into 7 is 77, entire thing divided by 11 into 24. Next again entire thing divided by, you have here 11 into 24, you need to multiply to this one. So it will become 11 into 24 here. Next minus, this minus is here. Next 2 into 7, 14. So again entire thing divided by 11 into 24. Students, here no need to simplify this 11 into 24, because in numerator as well as denominator we have the same number which you can cancel. So don't waste your time in multiplying these two numbers. Simply you can cancel them. Then you simplify the other things, that is 48 plus 77 you write as it is divided by 11 into 24 is 264 minus 14. Next further you simplify, it will become tan inverse of 48 plus 77 is 125 divided by 264 minus 14 is 250. Still more simplification is possible. So you can simplify here. This is 125 one time, 125 two times. So it will be tan inverse of 1 by 2, which is our right hand side. So we proved this expression here. How we proved? we started from left hand side, then we applied the property tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Next, let us see the third problem, that is, show that 2 times tan inverse of 1 by 2 plus tan inverse of 1 by 7 is equal to tan inverse of 31 by 17. What you can observe here, students, in the left hand side, in previous problems you had tan inverse of a real value plus tan inverse of another real value, both were tan inverse, but here you have 2 times of tan inverse. So directly you cannot apply that property tan inverse of x plus tan inverse of y here. Okay, you need to use the property 2 tan inverse of x. So let us use the property 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square here. Okay, so let us take the left hand side. Left hand side you write this one as it is, then you apply the property to the first term, that is 2 tan inverse of 1 by 2. Which property? 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square. Let us apply this property only to the first term of our left hand side. So this 2 tan inverse of 1 by 2, by using this property we can write as tan inverse of 2x. So 2 into 1 by 2 divided by 1 minus x square, that is divided by 1 minus, what is our x? X is 1 by 2. So 1 by 2 whole square. Again you see we have to use this property 2 tan inverse of x is equal to tan inverse of 2 times of this value divided by 1 minus square of this value. So here 2 tan inverse of 1 by 2 will become tan inverse of 2 times of 1 by 2, entire thing divided by 1 minus 1 by 2 whole square, plus this tan inverse of 1 by 7 you write as it is. Now you simplify this first term. So here 2 and 2 you can cancel, and this 1 by 2 whole square will become 1 by 4. So 2 and 2 when you cancel it will become 1, and 1 by 2 whole square is 1 by 4, 1 minus 1 by 4 is a 3 by 4, plus this tan inverse of 1 by 7 as it is. Here you are having tan inverse of 1 by 3 by 4 means you need to take the reciprocal of 3 by 4, that is nothing but 4 by 3. So this expression will change us to tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now you have the sum of two inverse tan functions. Now you can use this property. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. So use this property here and simplify further. So it will become what? Tan inverse of, you need to add these two values. So 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. That is equal to tan inverse of, here again you have to take the LCM. So let us cross multiply. We are going to get 7 4s are 28 plus 3 1s are 3 divided by 7 into 3 is 21. Entire thing divided by, here 7 3s are 21. This you need to multiply to this 1. So it will become 21 minus 4 1s are 4 divided by 3 into 7, that is 21. Now again these denominators you can cancel out. So this is equal to tan inverse of 28 plus 3 is 31 divided by 21 minus 4 is 17. That is nothing but our right hand side. So this problem is an important one. Here we have used two properties of inverse trigonometric functions. Which are those two properties? Here in the first step we applied the property 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square. only for the first term of the left hand side. By using this property, we simplified this one and we got tan inverse of 4 by 3 after the application of this property. Then this one will remain as it is in each step, tan inverse of 1 by 7. Now you are having sum of two inverse tan functions. Now you can use another property, that is sum of two inverse tan function, which is given by tan inverse of x plus y divided by 1 minus xy. So we used this property and we did furthermost simplification, and finally we got our right hand side. Next, let us see the fourth problem. So fourth problem is, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. So what you can observe here, students, left hand side you have sum of inverse of two cos functions, and here also you have a cos inverse, but we have the property for tan inverse. Up to now in previous problems we have used the property tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. So here what we will do is we will convert this cos inverse in terms of tan inverse. So let us see how we can convert cos inverse to tan inverse. So let us take one term each. Okay, first let us take this first term, let us convert this one to tan inverse, then we will take the second term, then we will convert that to tan inverse. So let us take the first term now here, that is cos inverse of 4 by 5. You take that as x, then cos x will become 4 by 5. You know all trigonometric functions are defined on right angle triangle. So let us take the right angle triangle here. This angle is 90 degree, this angle is x. And cos x, how it is defined? Cos x is adjacent by hypotenuse. So you can take this 4 as your adjacent side and 5 as hypotenuse. Next, you can find the opposite side by using Pythagoras theorem. Or else you can remember these numbers as Pythagorean triplet. 3, 4, 5 are Pythagorean triplet. So you will find the opposite side of this triangle as a 3. Next, let us find what is the tan x from the same this triangle. So tan x will be equal to opposite by adjacent. So it will be 3 divided by 4. So tan x we got as 3 divided by 4. What that implies? X is nothing but tan inverse of 3 by 4. This x is cos inverse of 4 by 5. So here we have with us cos inverse of 4 by 5 in terms of tan inverse as tan inverse of 3 by 4. Let us take this as equation number 1. So what we did here, we converted cos inverse to tan inverse. Cos inverse of 4 by 5 we wrote as tan inverse of 3 by 4. Next, let us take the second term of our left hand side, that is cos inverse of 12 by 13. So let us take this cos inverse of 12 by 13 as another angle y. Then cos y will become 12 by 13. Again you take the right angle triangle, and cos you know it is adjacent by hypotenuse. So this 12 will become adjacent side and 13 will become the hypotenuse. You can find the opposite side again by Pythagoras theorem. So that opposite side will become as 5. Next, find what is tan y. Tan y is what? Opposite by adjacent. So it will be 5 by 12. So if tan y is 5 by 12, then y will be tan inverse of 5 by 12. And this y is nothing but cos inverse of 12 by 13. So here we converted this cos inverse of 12 by 13 in terms of tan inverse as tan inverse of 5 by 12. Take this as a equation number 2. So up to now what we did, we converted these two inverse cos function in terms of inverse tan function. Cos inverse of 4 by 5 changed to tan inverse of 3 by 4, and cos inverse of 12 by 5 changed to tan inverse of 5 by 12. Now use this in solving this problem. So let us take the left hand side now. Left hand side you have these two cos inverse term. Then next step we will replace those cos inverse term in terms of tan inverse. So let us take the left hand side. You had two cos inverse terms. Then we shall replace these cos inverse term in terms of tan inverse, that is from equation 1 and equation 2, which we considered in our previous slide. So cos inverse of 4 by 5 is nothing but tan inverse of 3 by 4, and cos inverse of 12 by 13 is nothing but tan inverse of 5 by 12. Now you have the sum of two tan inverse, so you can use the property tan inverse of x plus tan inverse of y, which is given by tan inverse of x plus y divided by 1 minus xy. So use this property here now. So this will become what? Tan inverse of, add the two values here in the numerator. So it will be 3 by 4 plus 5 by 12 divided by 1 minus 3 by 4 into 5 by 12. Next you simplify this. So again here you have to take the LCM. So what we will do? We will cross multiply here. 12 3s are 36 plus 4 5s are 20 divided by 12 4s are 48. Entire thing divided by, here you multiply these two first, 12 4s 48. 48 you need to multiply to this one. So it will become 48 minus 3 5s are 15 divided by 48. Next you can cancel these 48. So this is equal to tan inverse of 36 plus 20 is 56 divided by 48 minus 15 is 33. We had in right hand side of the question also in terms of cos inverse only. So now we need to convert this tan inverse in terms of cos inverse. So what we can do? Again we will take this tan inverse of 56 by 33 as z. Then tan z will become 56 by 33. Next you take a right angle triangle. Tan, how it is defined? The tan is opposite by adjacent. No. So opposite side is 56, adjacent side is 33. You can find the hypotenuse by using Pythagoras theorem, and that hypotenuse will be 65. So once you get the hypotenuse, you can find what is cos z. Cos z will be adjacent by hypotenuse, that is 33 by 65. So you will be having this cos inverse of, that z is given by cos inverse of 33 by 65, which is same as tan inverse of 56 by 33. So this one what we got is nothing but our right hand side. Cos inverse of 33 by 65, which you can see in our previous slide. We got cos inverse of 33 by 65. So this is of our fourth problem. So what we did here, students, first you converted, because in your left hand side you have two cos inverse. First you have to convert that cos inverse to tan inverse. Okay, then you will use the property of a tan inverse. Next let us solve the next problem, that is prove that tan inverse of 63 by 16 is equal to sin inverse of 5 by 13 plus cos inverse of 3 by 5. So if you see this expression, in right hand side you have got two inverse trigonometric functions, that is one is sin inverse and one is cos inverse. In previous problem we had two cos inverse functions, right? So here you have one sin inverse function and one cos inverse function. So first task is, let us convert this sin inverse and cos inverse in terms of tan inverse. So let us take the first term of our right hand side, that is sin inverse of 5 by 13 as x. Then sin x will become 5 by 13. Next you take a right angle triangle and you can find the sides of this triangle by this trigonometric function. Sin x is equal to 5 by 13. Sin x, how it is defined? It is opposite by hypotenuse. So opposite side will be 5, hypotenuse will be 13, and you can find the adjacent side by using Pythagoras theorem. It will be 12. Next you find what is tan x from the same right angle triangle. So tan x will be opposite by adjacent, so 5 by 12. Then x will become tan inverse of 5 by 12. That x is nothing but sine inverse of 5 by 13. So we got sine inverse of 5 by 13 in terms of tan inverse as tan inverse of 5 by 12, which we can take as equation number 1. Next you take the second term of the right hand side, that is cos inverse of 3 by 5, which you take as y, then cos y will become 3 by 5. Again you consider the right angle triangle. Cos is defined as adjacent by hypotenuse, so it is 3 and this hypotenuse is 5, opposite side will be 4. So from this triangle, now you define what is tan y. Tan y will be opposite by adjacent, so 4 by 3. So y will become tan inverse of 4 by 3, that y is nothing but cos inverse of 3 by 5. So we have with us now cos inverse of 3 by 5 in terms of tan inverse as tan inverse of 4 by 3. So take that as equation number 2. So what we did? Sin inverse we converted in terms of tan inverse as sin inverse of 5 by 3 became tan inverse of 5 by 12. And cos inverse of 3 by 5 became tan inverse of 4 by 3. Now let us consider the right hand side of this equation. Replace this sin inverse in terms of tan inverse. Instead of sin inverse of 5 by 13, you write a tan inverse of 5 by 12. And cos inverse of 3 by 5 will change us to tan inverse of 4 by 3. So let us consider the right hand side, that is sin inverse of 5 by 13 plus cos inverse of 3 by 5. Now you replace. Sin inverse is replaced by tan inverse of 5 by 12 and cos inverse of 3 by 5 is replaced by tan inverse of 4 by 3 from equation number and equation number 2, which we saw in our previous slide. Now you apply the property tan inverse of x plus tan inverse of y. So let us apply that property. So by using that property, we can write this one as tan inverse of 5 by 12 plus 4 by 3, entire thing divided by 1 minus 5 by 12 into 4 by 3. Next let us simplify this. So it will become tan inverse of, again you need to take the LCM here, so let us cross multiply. 3 5s are 15 plus 12 4s are 48 divided by 12 3s are 36, entire thing divided by, here 12 3s are 36, you need to multiply to this one, so it is 36 minus 5 4s are 20 divided by this 36. You can cancel these 36, so you are left with the tan inverse of, add these two, 15 plus 48 will give you 63 divided by 36 minus 20 is equal to 16, which is nothing but our left hand side. You can see here in our left hand side we have tan inverse of 63 by 16 and we got here as tan inverse of 63 by 16. So students, here in class we have solved few important problems of this chapter, inverse trigonometry. So note it down in your notebook all these problems.